Bismillahirrahmanirrahim. For the last subtopic, 4.4 is the normal approximation to the binomial and Poisson distribution. Okay, remember binomial and Poisson you have covered from the previous chapter, chapter 3. And normal is in chapter 4. You have several criteria to consider. Let's say for the first one, when you want to approximate from binomial towards normal distribution, you know that binomial, the parameter is n and p, while for normal, the parameter is mean and also variance. So the condition for you to use normal from the binomial question is NP must be at least 5 and your P, probability of the success event, must be from 0.1 up until 0.9 only. So if you satisfying these two conditions, you can use normal distribution method. So how to use normal? You must have the mean and also the variance value. So how to find the mean? Is equivalent to NP. Mean for binomial is NP and variance for binomial is NPQ. So you will use these two formula to have the parameter for the normal distribution. And then the second one, when you have the Poisson distribution question, then you want to use normal method. Parameter for Poisson is lambda. And parameter for normal is mean and variance. The condition that must be satisfied is lambda value must be more than 30. So you have only one condition. If you satisfy one condition, then you can use normal distribution method. So to use normal, you have to find the mean and variance value. Recall back the mean for Poisson is lambda and the variance for Poisson is also lambda. So this is how you can use the normal method from the binomial and Poisson question. Okay, one more thing that you have to consider is binomial and Poisson is about discrete random variable or discrete data, but normal is about continuous. So you have to do something when you want to approximate from the discrete data towards continuous data. So that one we call as the continuity correction. So this is the first step when you are using normal approximation from binomial and Poisson, which is from discrete towards continuous data. Okay, let's illustrate the bar graph as the discrete data 1, 2, 3, 4, 5, 6, 7. And then the pink color graph here, let's say this is your continuous data. Okay, so let's say the question from the discrete want you to find the probability of x equal to 4. X equal to 4 meaning that you are finding bar number 4 here. But when you convert to the continuous data, which is normal distribution, so bar number 4 is actually starting from here up until end of the bar. Okay, so how can you write this interval? You can have probability of x is from 3.5 up until 4.5. This is how you are using the continuity correction method, meaning that bar number 4 is actually starting from 3.5 up until 4.5. And then it doesn't matter whether you have the equal sign or you doesn't have the equal sign, because normal just cover area under the curve. So area under this curve is starting from 3.5 up until 4.5. Okay, that is when you have the equal sign from discrete. Let's say you have the inequalities. Number 2, x is more than 2. X is more than 2 meaning that the coverage is from 3, 4, 5, 6 and 7. Okay, you are having from bar 3 up until bar 7 here. Then when you want to convert to the continuous data, so bar number 3 is actually started from this value, which is 2.5. So you can write as Px is more than 2.5. Alright, move to the third one. X is more or equal to 2. You have included the 2 value, so this bar also included. So if you want to convert to the continuous data, this is actually started from 1.5. So you can have P x is more than 1.5. Okay. Let's say we are having number 4. Px is less than 6. Less than 6 meaning that 5 and below. This is bar number 5 and below. Okay. So this is the coverage when you have x less than 6. Then when you want to convert to the continuous data, bar number 5 here is actually n at this value, which is 5.5. So you can write as probability x is less than 5.5. Okay, meaning that when you convert to the continuous data, you will refer to the pink color graph too. So pink color graph is starting from this point and below. Look at number 5. You have x is less or equivalent to 6. Meaning that bar number 6 is included and below. So this is all the included value. Then how can you write for continuous data? Continuous data is actually started from here. So you have probability of x is less than 6.5. So started from 6.5 and below. That is the coverage for continuous data. So it doesn't matter whether you put the equal sign or you doesn't have any equal sign, because the starting value is still here. Okay, because you want to find the area under this curve only. Let's say you have in between number. X is from 3 up until 6. So 3 up until 6 meaning that you have bar number 3 up until bar number 6. So this is the bar covered. 3, 4, 5 and 6. So 4 values covered for discrete. But for continuous, it's actually started from this value up until this value. So when you convert to continuous data, the starting point is from 2.5 x up until 6.5. Okay, that's how you convert from discrete data to continuous data. This method we call as the continuity correction. So this is the compulsory step when you want to approximate normal from binomial question and also Poisson question.